let's look at this vector question. The displacement from a fixed origin at sea level of a passenger riding on a gondola is modeled by this equation, where t is the travel time starting at the base station and ending at the top station. Distance is measured in meters. So Bill boards the ski lift from the base station and travels to the top station. So this is a 3D vector because we have x, y, and z values. But to visualize the scenario, I'm drawing it in a 2D plane. So from B, we're going to T. So that is the scenario. So the first question asks, write down Bill's initial position. So this is testing on our knowledge about vector equations. Vector equation actually consists of the starting point, a constant, which in this case is time, and the velocity vector. So the question asks for initial position, and we know it is this one here, the starting point values, but this is in vector form. So all we need to do is change it to coordinate form. So I'm going to give it the name B, 2, 4, 4, 12, 1, 6, 5, 0. Next question asks, what is the velocity vector? So basically how fast it is moving in x, y, z direction. And the velocity vector is always attached to the constant. So in this case, it is 2.4, 5.2, and 1.8. Find the speed in meters per second of the gondola ski lift. We actually have a formula to calculate speed, which is the magnitude of the vector. So all we need to do is put in these values and square root them as well as plus them all together. For question C, it says that it takes k minutes for Bill to reach the top station, which has a vertical height of 2352 meters. So the keyword here is vertical 2352. X, Y, or Z equation is equal to 2352. And how are we to know? X is either to the right, or left, as you can see the diagram. Y is front or back, and Z is up or down. So in this case, which one do you think is equals to 2352. Now, if you guessed Z, then you guessed correctly. Because why the answer is Z is because it says vertical height. So vertical is to do with up and down, or like this plane lah, up, down. So we will take the Z equation, which is 1650 plus 1.8 T, 352. And then we'll get T as 390 seconds. But keep in mind they want the answers in minutes. So we're going to divide that by 60 seconds and we'll get 6.5 minutes. For the next question, it asks to find Bill's terminal position. From the previous question, we already found how long it takes for Bill to reach the top station. So all we do now is we substitute this time into the given equation so that we can get the terminal position. Remember to use the 390 and not 6.5 because the equation uses the time in seconds as stated over here. In the end, we will get 11802040 and 2352. So to get this answer, just to run you through, so what you do is you take, you can just straight away put in the GDC 244 plus 390 times 2.4, and you'll get this value, and you repeat the same for the other two equations. Question asks for the length of Bill's ride. So for this question, we can use the distance between 2 points formula, whereby it is the final x value minus the initial x value squared plus with final y value minus initial y value squared plus with final z value minus initial z value squared. Get 2341.3 meter. Now for the next question, it asks find Bill's position when he is closest to a skier resting on a hill at the point P. So on Bill's way of getting from the base station to the top station, he is closest to a point P, let's say it's here, and we want to know when is he closest. So Bill could be here, 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 or here, or anywhere on this line, but the point that Bill will be closest to P is when he is perpendicular to P. And to find that intersection value, we need to use the formula A dot B is equals to 0. Our A will be this line over here, which we need to find. And how we can find it is by minusing the final vector equation minus the initial vector equation. So this vector equation of BT minus OP. So the BT equation is the one that they give in the question. 2, 4, 4, 12, 1, 6, 5, 0 plus C minus with the vector OP, which is basically the P coordinate. This is us finding the vector A first. So we're not doing the dot product yet, we're just finding A. So put this all in your GDC, you will get these values. So now that we're done with A, our B will be the velocity vector of BT, which is 2.4, 5.2, and 1.8. Now let's do the maths. Now we have to solve for T. So how we expand this bracket is by times 2.4 with this value and times 2.4 with this value. and do the same for the other two equations. In the end, we'll get this equation over here. In the end, we'll get 180 seconds. It takes 180 seconds for Bill to get to the point over here. So to find what is the coordinates of that point, I have to substitute this 180 to the vector equation of BT. And in the end, we'll get 676,948,1974, which will be this point over here. Very good morning, everyone. So today I will be covering the subtopic of Voronoi diagrams. Okay, so the first thing that we will look at are the common terms that are used in the questions. The first term is cell. So cell is what we call like the regions that contains any alphabets, or alphabets is also known as the site. And this is the region that contains site B. Okay, so the next thing is this line separating site site B and site C. This is known as the H. And the point, this point that where the line meets are what we call the intersection. What is Voronoi diagram? I like to look at Voronoi diagram as like a map that contains many smaller regions. Or in this case, a map that contains region B, region C, and region A. How to construct Voronoi diagram? So, we have to remember that Voronoi diagram is based on series of perpendicular bisectors. This line separating each sites or region are the perpendicular bisectors. So, for example, site A and site C, the perpendicular bisector is this line. Or for site B and site C, the perpendicular bisector is this one. Okay, so let's move on to the concepts that can be applied under the topic of Voronoi diagrams. The first one is the nearest neighbor interpolation and the toxic waste dump problem. So nearest neighbor interpolation is where is the concept that we use to do estimation. And the toxic waste dump problem, if you look at like a situation where we want to throw away like toxic waste product, so we want to throw it far away from a place. So that's why we apply the toxic waste dump problem. Let's look at the sample question that I have provided. So, consider the Voronoi diagram below with sites A, B, C, and D, and intersection E and F. Okay, so first question A. Determine the site closest to the coordinates 9 and 6. Okay, so I have marked the coordinate, and this is the coordinate, the one marked in yellow. So the site that is closest to the coordinate 9, 6 is the site. So the answer is site A. So for question B, determine the coordinates of the center of the largest empty circle. So for question B, this is the type of questions where we apply the toxic waste dump problem. So we have to use the intersection point to act as the center of the circle. So next step is we use the formula of distance. We will calculate the distance from the intersection to any point or any sites. So I'm going to use the site A. Okay, so to calculate it, we have to calculate the distance of FA. So we will get this working, and the answer is 4.47124. And next we will calculate the distance for E and A, and the final answer is 4.12311. Given three significant figures, we will get 4.12. So the largest empty circle will be distance from F to site B. Okay, so calculate the area of the largest empty circle. So the area, this is where we apply the formula pi r squared. So by applying to this formula, we will get put the radius that we have gotten from the previous question, which is 4.47214, and the answer will be 62.832 or 62.8. So I have added another question to cover all the concepts in Voronoi diagrams. So basically it says that A, B, C, and D are coffee shops in famous area in Paris. So this guy Robert wants to open another coffee shop near coffee shop C. So they're not open here, C. So let's say he wants to put the shop here. Okay, so he wonders how many customers will come to buy coffee every day in a week. So he wants to know what concept can be applied to clear out his wonder. So this is the situation where we will be using the concept known as the nearest neighbor interpolation that to estimate the number of customers in a day. Okay, so for example, if given like the site C has 1,000, if site C has 1,600 coffee sold in 1 week. So the new coffee shop will also have the estimation of 1,600 coffee shops in a week. So I guess that's all for my explanation on Voronoi diagram subtopic. I hope you understand. Thank you very much.